Hello again, Chaz here. We are talking about electron geometry today for our in-home experiment. Today I don't have any of my kids with me, but they're all in bed. It's a little late here. But we are doing balloon geometry and talking about the electron domains of elements and compounds and where they might be in the different shapes that they create. And so we'll just get started right off. For the first one, we are talking about the, I'll just go ahead and hold this up, but we are doing sulfur dioxide. It's SO2, and the number of domains that it has, the electron domains, is 3, and the type is AB2, and the electron domain geometry is trigonal planar and has a one lone pair of electrons. And what that looks like, I have it here. What that looks like is right here. So we have the 3, you can see the 3 electron domains, 1, 2, and 3, where those electrons might be within that sulfur dioxide, with a lone pair possibly being right here in the center. Okay. For our next one, we have we're going to call it ammonia, and it's NH3, and there are 4, so there's number of electron domains is 4, and we have the type is AB3, and the electron domain geometry is going to be tetrahedral since there are 4 domains, and the number of lone pairs of electrons is 1, excuse me. And the shape of that I have right here, created in my model with the balloons. And so we have the 3, back it up here. So we have the 3 that goes around, and with the 1 up top, creating this tetrahedral look about it, with the lone pair of electrons that can be right here in the center. Okay. Moving on to the next one. For our next one, we're going to go with water. Now, water again is tetrahedral, but it is an AB2, and it still has 4 domains. This gives that tetrahedral shape, and this one has 2 pairs of lone pairs of electrons. Okay, so for the water, excuse me. Okay, so again, water is going to be tetrahedral, and so it's going to have this same kind of shape, but it's going to have 2 lone pairs of electrons. So the electrons are going to be anywhere within these 4 areas, but the actual geometry of it is different. It being, having just it's H2O, and the other one was NH3. And so the geometry has 2 lone pairs instead of just 1. And so, but the electrons can be anywhere within that tetrahedral shape. Okay, so moving on, we have next is sulfur tetrafluoride. With sulfur tetrafluoride, it is SF4, and number of electron domains is 5, and the type is AB4, and the electron domain geometry is trigonal bipyramidal. And that number of lone electron pairs is 1. And to get that shape, and for that sulfur tetrafluoride, I've added to our model here again. So we would have the 1 balloon at the top with the 3 along the outside, and then the 1 more added to the bottom there. And so it looks something like that. I'll try to scoot back so we can see that better. See that? It's getting bigger. Without the 1 lone pair being there in the middle somewhere. Okay, but electrons could be again anywhere within those different domains. Another example of the trigonal bipyramidal is this chlorine trifluoride, which is ClF3, and that again has 5 domains, but it is an AB3. Okay. And it has 2 lone pairs of electrons, but again giving that same shape, but it just will change with the actual geometry, the molecular geometry of it will change, but this is the same shape that those electrons and bonds will create. With that, even though it's the difference is it's the AB3 and it has 2 lone pairs of electrons. And for our last but not least, we have a bromine pentafluoride. And bromine pentafluoride looks something like this, where it has 1 more in the middle. And I can go and hold this up. The bromine pentafluoride, BRF5, has 6 domains, and it's octahedral, and the number of lone pairs is 1. Okay, so now octahedral. It's like this. It has the 1 in the center, or the 1 on top, and now 1 on bottom, and 4 around the midsection. Kind of a crazy shape. Kind of cool there, but again, this is where the electrons of the BRF5 are going to be somewhere within this shape. The other one that would give us this shape is a xenon tetrafluoride, which is XeF4, but it has also 6 domains, but it is AB4. So it has 2 lone pairs of electrons, instead of just the 1, like the BRF5. But again, it's the same story. Looks like this, kind of peculiar looking, but it's pretty cool. And this was very helpful for me to be able to learn and figure these things out and learn the geometry of these. I hope it was beneficial for you. So thanks for watching, and we'll see you in the next one.